Et vous voyez quelque chose là ou?
Ouais, on voit des trucs.
Ok.
Ah, on voit tout
Let's
même.
go. So I
C'est
switch
trop la
in
classe.
English.
Yeah.
In English, yes.
Can,
Okay.
of course, my dear friend.
Okay. So let's start. So it's just an experience report, a fun story. I think I had. So I just want to share with you, and maybe it can lead to something more profound, let's say. So everything started with a message in social media, not to say Facebook, right? And a friend of mine, a chess player, he challenged people, right? He says that you have to resolve the following problem. Given a traditional chessboard, so 8 by 8, your goal is to place 4 screens and 1 bishop so that all squares of the board are controlled. So the 64 squares. So I'm not sure you're all familiar with chess, but I will quickly remind you.
I'm sure, yes.
Yeah, so you have the queen, right? The queen can control the horizontal lines and the vertical lines, as well as the diagonals. And the bishop can only control the diagonals. So 4 queens, 1 bishop, and you have to control all cases. So here I have a GIF, an animation that shows some placement of pieces. And you see the number here, it's the number of cases you miss. So at the beginning, yeah, you miss a lot of squares, right? Because they are not controlled neither by the queen or the bishop. And then you try some solution, right? And maybe you get the full control, the 64 cases. So we can play with light chess, right? So you can start like that. And then you can realize that some pieces are not well placed, like this square. So of course, totally yes.
How many combination regarding the problem? It's 1,000, 100, and 1,000.
I made some maths. It's something like that. Here, I will discuss afterwards.
Okay, sorry.
No problem. It's this number. It's huge, right? It's huge, but as human, we are very smart, so we are not trying some stupid stuff. But even if we are smart, it's kind of hard to read the 64 control, right? Because of course it's totally unrealistic. So it's not a real chess game, right? It's really for fun, and it's quite different from the n queens problem. Maybe you have heard about that in a constraint programming course at university, because the goal is to place 8 queens so that they don't cross each other. But here it's a bit different, right? It's another puzzle, another problem. Unrealistic, but kind of fun. So what you can do when you see this kind of message on social media, right? You can basically ignore them because there are many puzzles or stupid games that are placed there. Or you can try with a physical board or with the light chess editor. But here, yeah, I say, okay, why not programming a solution? I mean, in fact, you're trying lots of solutions, and maybe at the end of the process, you will find one. So I launched the Jupyter Notebook. I wanted to program a Python solution to this program. So I reflect a bit, right? So you have a chessboard, and you can represent like that. The 0 digit is for this square, and the 63 digit is for this square, right? And you can represent each square with a number. And the algorithm looks quite simple. You try all possible placement of 4 queens and 1 bishop, and then you assess each placement, and you hope that you reach 64. So for generating the combination, you can generate 5 numbers, 4 numbers for placing the queen, and 1 number for placing the bishop. So it's what I did here basically. I first select a number between 0 and 64 4 times, and then I place the bishop here. So okay, and you have to be careful because if you're very naive, you can explode the Python stack because the number can explode. There are some symmetries, right? Because the queens, the 4 queens, you can change the way they are placed. It's the same. So you can exploit this trick to scale basically. So you generate the combination, and in fact the total number is here. So it's a lot, but we have a computer, a fast computer, so we'll get it. And once you have generated all possible combinations, you have to assess whether it's a good solution. And for doing that, you need to compute the control squares of queens and bishop. So what I did is that I made some functions to generate the squares controlled by each piece, right? So you need to have an implementation, right? So I compute all vertical direction of a piece, all horizontal direction, all diagonals, and at the end I have function like that: squares covered by queen, squares covered by bishop. Okay, it's a bit technical, right? And then I can compute the number of cases that are covered by performing the union of squares covered by queen and bishop, and hopefully it's 64. You get it?
Yes.
Okay, and so then the algorithm is quite simple. For each combination, you compute the number of cases that are covered, and if it's 64, you win. Okay. So of course I found a solution, and I was quite happy because doing it on a real chessboard was a bit of hard. But yeah, I was a bit surprised by something, is that you know, I have this psychological issue like many programmers. I'm not saying all programmers, many, that I was thinking that this task, this programming task, should take a few minutes, like 1 hour. Of course, there are kids at home and so on. I'm disturbed sometimes, but still, it takes to me, I think, 4 hours or something like that, which is kind of strange. So I have some scaling issue with combination. I overestimate this. I have to remember how to properly represent the board, and I have to hardcode the movement of pieces. It's not that easy because, yeah, you have to remember the math, and also I forget the case where the square controlled by a queen, and when there is a bishop in between. So it's a subtle case, but that's a total bug that I forgot, and I have to iterate. So something like 3 or 4 hours. And for me, it was a bit of strength to take so many times to do that. So in fact, yeah, I was asking some question, and Luc replicated the experiments. Replicated meaning that he find also a solution. So I have a notebook of Luc. He made a very nice implementation. So it's a bit different than me, but in principle, that's basically the same. So he used NumPy, right? Because he's a real data scientist. He plots nicely a chessboard with matplotlib. And he defines some abstraction for representing a piece, a bishop, and for computing the cases controlled by each piece. A bit like me, right?
Yes, with real object-oriented design.
Yes, because he had awesome courses at NCI, of course. So yeah, and the queen, yeah, that's nice, right? And he made a board with with cases that are controlled or not, and so on. And then he has an algorithm which is here. Let me check. That, yeah, basically generates some combination. And yeah, when he finds all pieces, you win. So he tries many strategies for exploring the space. One is purely random, one is a bit greedy. The greedy one didn't work, if I really remember, and the random one did work. And yeah, he found a solution. So congratulations to Luke. It was a nice implementation and he found a solution. But I think it was like me, right? I haven't asked Luke, but maybe I will do afterwards or during the coffee. But I think it takes some time, right, to do that. What do you think, Luke? Is Luke here?
Yes, it takes some time.
Yeah.
But not so long, I think. But the real problem is to determine all the solution, not just one.
Mm-hmm.
I think. But yeah, it takes some time.
Yeah, it takes some time. Yeah. So yeah, I was thinking about that, and then I say, okay, I have impression that I have reinventing a bit the wheel, right? In particular, the movement of pieces, it was a bit chaotic in my case. So maybe I was terribly bad here. I don't know, but still, I was thinking, yeah, maybe I should reuse something. And yeah, is there a chess library that can support our task instead of re-implementing the read? So I knew pretty well Python chess. In fact, I even write a blog post implementing a chess game reader. So I'm a big fan of this library, but I didn't use it because I was thinking the library was not designed for tackling my problem. And basically, I was thinking that the library would be unable to deal with invalid chess position. So here, for instance, there is no king, which is the rule on chess. And also the library is mostly for reading games, right? It's not for computing the squares control and so on. But in fact, I was wrong. You can hack the library and reuse some facilities they offered. Of course, the library was not designed at all for that, but you can somehow hack this library and you can quickly get an implementation. So for instance, here, the number of cases covered by all queens is just this number of code, this code, right? It's you initialize a board, you can clear the board, meaning that you can remove all piece. You set the piece, so queen, a bishop, and then you have a nice method, which is called attacks, that returns the squares controlled by a piece. So I think it was a bit incidental because, again, this library was not designed, but in fact, I could opportunely reuse this library to have a much more concise solution. And in fact, I made a mistake here, I think. Instead of spending 3 hours in reinventing the wheel, I should have reused this library and maybe it would have decreased significantly the time I needed to perform the task. So I have two competing implementation. One with reuse, right? One with my own implementation. Okay, so the first lesson here is opportunistic reuse. It's not a straightforward reuse, but yeah, that's one lesson I learned. It is now very obvious. And maybe
did you compare the performance?
Yes, so the performance is I think it's better with the reuse solution. Okay. Yeah, but I think it's the case of many libraries, right? They are not designed for resolving your problem, but with a bit of hack and with a bit of luck also, because there are some good methods for you. You can maybe tune in the library and fit in for your own problem. But yeah, I made this one. Okay, so I find a solution. And in fact, there are many solutions, right? I compute some statistics and so. Okay. So we are here. Okay. It's here. Wow. The Zoom stuff this time. Okay. So now we have a solution, right? A quite concise solution, and I was quite surprised by the conciseness of the solution with the opportunistic reuse solution. I was thinking, oh, why not decreasing the number of characters so that it can fit in a tweet, so that I can resolve this chess puzzle in one tweet, because a tweet is no longer than this number of characters. So my basic motivation is that, okay, opportunistic reuse drastically reduce the amount of code, sorry. And interestingly, there are also some initiative in the chess domain for implementing a chess engine with the least number of codes. And there are also chess engines that fit into this ridiculous amount of bytes. So it was quite funny, right? And also, I was quite inspired also by people that are doing this beautiful piece of art just with a tweet. I mean, with this line of code, right? You can draw this nice art. So it's in Python. And in fact, they are reusing what? They're reusing processing, which is a library. And processing, for me, it's a bit like Python chess library.
Yeah, you have to discuss with Benoit Baudouin, because he has also gathered lots of CSS code or really JavaScript code for doing such kind of stuff. Because it's the same, you can do really complex stuff in just writing some CSS.
Yeah. Yeah, it's amazing. Here it's just Python and C code examples. Yeah, but that's kind of amazing. And yeah, I will discuss with Benoit about that. Yeah, but here I think the success is also because of some high-level library that reduces drastically the effort you need to make and also the amount of code. But I don't know how CSS deal with library and reuse, but yeah, interesting discussion to have. So it was my basic motivation, right? And I start with something here, so a really concise solution. So it's an interesting exercise actually to make a code very concise. It allows you to discover some strange construct of programming languages, and also think deeply about language constructs. So I can comment a bit. So I have to save some space, right? And instead of calling chess.something, now I just have to call it C, which saves some characters. It can surprise you, the W equal true, but I'm using true in different places. If I'm using true in 2 places, it's 8 characters, 4 multiplied by 2. Here it's only 6, so it pays off at the end. And then some acts like that, right? And at the end, you fight, and you can reach the graal, which is this number of characters that fits in a tweet. So very elegant, right? And if you reinvent the wheel, you cannot have a concise solution like that. And then I follow I continue the story, and in fact I found new opportunities to save some space. So here it's a bit tricky, but the set piece it takes a lot of character, right? And it's called 2 times here. And I find a way to factor out the call by putting the kind of pieces into an array. So now you have queen, 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 bishop. 3 is for bishop and 5 is for queen. And I can even do some more sophisticated stuff like that. And you can continue. yeah, it's kind of fun. And in fact, by doing this exercise of having a tweet solution, in fact, I generalize incidentally my solution, because it forces me to think about what is essential to my solution. So in fact, I made some progress, and of course there are other chess puzzles that pop out. For instance, my friend made a new one. He challenged us to find a solution to the following problem. You have a 6x6 board. You have to place 3 queens for control all squares. Okay, so here, what's challenging is that the Python chess library was not designed for handling the chessboard 6x6. It's designed for real chess games. So it's designed for chessboard 8x8. So you have to hack a bit and have some filters to remove some cases here. So that's what I did here. It basically controls, it basically filters out squares that are in the 7th column and the 8th column and 7th line and 8th line. And then you have the combination, and you can quickly find a solution. It fits in a tweet again. Okay, so then I was thinking, okay, maybe I can generalize, because I have solved many 2 puzzles. Maybe I can find a solution to any chess puzzle. So I was thinking, I have some parameters, right? Like the number of columns and the number of lines in the chessboard, the number of pieces you want to place in your chessboard, the kind of piece you want to place. So it can be queen, a knight, a rook, whatever. And then you have some predicates about the kind of property you want to find, like you control all cases. But there are also different problems, like it's a puzzle I invented myself, basically. It's the problem of placing kings in a distant way. So you cannot see it, but basically, yeah. I invented new problems by doing that. And at the end, I have a kind of DSL. So very simple DSL, because there are parameters and some predicates and so on, but still it's kind of DSL. When you specify the kind of puzzle you want to resolve, right? And it's very generic. So thanks to this DSL, I could quickly verify whether there are some solution to a puzzle. And for instance, can you place 5 bishop plus 3 knights plus 1 rook for controlling all cases? And you can change all parameters that are here and there, all the predicates, and you can resolve many kinds of puzzles, right? Yeah, and I did that with the 8 queen problems, the famous one that we all know at university. And yeah, so I have a kind of DSL for resolving any kind of puzzle. And then moving forward, I was thinking, okay, now maybe it could be very interesting to generate puzzle instead of just finding solutions to puzzle. So it's quite interesting from an intellectual point of view to propose some puzzle, because you're a designer of something and you have to think about something which is kind of hard to resolve, kind of elegant, kind of nice, kind of yeah, addictive, I would say. So of course it's kind of art, but maybe we can assist people, or maybe a computer can find interesting puzzles. And the algorithm will be like that. So you have a function generate puzzle. So in the specific case of chess, you take different inputs. So that's the specification, that's the DSL program, number of column, number of line, the pieces you want. And the pieces can be heterogeneous, so it can be not only queens, but also queen with rook or king, etc. And then the predicate of your puzzle, so the properties that you should respect. And then you have also some notion of validity. So validity in the semantic domain. So it means that you have a puzzle and you want to check that the puzzle has at least one solution. Maybe you want to verify that it has an unique solution, because that's the beauty of the puzzle. And yeah, you can certainly specify something here about your puzzle, but not everything. So you will generate some puzzle. If it's valid from a semantic point of view and from your own criteria, it will pass. And then you will ask to a human if it's a nice puzzle, because the aesthetics of a puzzle, the difficulty of a puzzle, it's quite subjective. So here you have to ask to a domain expert, right, whether it's worth doing. Yeah. So I have asked to a friend, so I haven't time to properly despite it, but basically I had a discussion with some grandmaster's friend about the difficulty of some chess puzzle. So I use my generator of puzzle, right? And I ask whether this puzzle with 6 bishops, 2 knights, 1 rook is hard for them. And yeah, the discussion that it was not, for instance, for this problem. It was really easy for them to resolve it, despite the fact that the computation, the program takes a lot of time to find one. So for example, on my computer, it takes 6 hours to find one. And I asked them, it took 1 minute for them to find a solution. So it means that, yeah, humans should be in the loop for generating interesting puzzle. And that's the beauty of the stuff. So I'm a bit lost. But I'm quite interested by this loop now. Sorry. Okay. Sorry about that. Yes. Here. Yes, I'm quite interested by this loop, right? So generate a puzzle, control whether it is valid, and yeah, ask to human whether it's worth investigating. In fact, it really looks like mastering a space of solution. So for me, it's really related to what we are doing in research about configurable systems. So we have plenty of configuration. We are controlling whether they are valid or not, and sometimes we are even asked to experts because yeah, some solutions are subjective. So it's really close, for instance, for very LaTeX, when you want to find a PDF that is valid, but also aesthetic, that does not alter the content. And here only a human can do that. So that's quite interesting. I have continued the stuff with other problems than chess, but maybe I'm taking too much time here. I will share you my code, but basically I have encountered this puzzle on social media again, and then instead of manually resolving it, I have wrote some Jupyter notebook to resolve it, and the same kind of experience. I find a valid solution, and then I've tried to generalize it to another kind of puzzle, etc., etc. And now the question I have is, how can I generate puzzles that are worth investigating? So that's it for me. I will share the code, and yeah, it's just a reflection about programming, about languages, about domain-specific languages, about computational thinking, you know, resolving problems with computer, also with complexity, with artificial intelligence. because complexity can mean very different stuff. And also it's kind of an instance of our research problem with configurable systems. Yes. Hello?
Yep.
Yep,
Really
thanks a
nice.
lot. It was really fun. Just to come back on this idea of thinking about DSL based on trying to start by finding the right abstraction. Do you, because you target two problems, do you see some common patterns of something that could be also guide someone that want to understand what could be the right abstraction for his own DSL? I don't know if I'm clear, but my question is there a way to guide someone that want to do this exercise? Because I think we do something automatically because we used to manage such kind of abstraction, and sometimes it's really hard to teach. And if we want to help someone to find the abstraction, it could be really based on code that exists. It could be fun to have some rules to help doing that.
Yeah, so at a very abstract level, I think the loop of the problem is a bit the same. It's generate some solutions, not to say all, assess the solution, and iterate again. But in this very abstract algorithm, you have different way of exploring the space. So you can do it randomly, you do it with greedy algorithm, or you can do it with genetic algorithms. You can do it only on a very simple way. I also hard-code some heuristics, so it's more weighted sampling. For instance, for placing the pieces close to the center. So basically, if you're a DSL designer for this kind of problem, you have to offer the opportunity to place some knowledge inside your loop. And it's the same for the assessment. So at the very abstract level, yeah, I think I have a kind of abstract algorithm that can be reused, but it's more a method, right? Then finding your good abstraction for your specific levels, it's very specific. It's what makes a difference. But yeah, maybe we can have some challenge here. In fact, you can try my methodology. When you find a puzzle in the social media or whatever, you can try to program it.
Do you try to program the Sudoku?
No.
No.
I didn't try. No, but that's really an instance of this. But Sudoku, no, because it's quite well known. And also, I know with Sudoku that you can resolve it with constraint programming. In the same way you can resolve the n-queens problem with constraint programming. But for the kind of puzzle I have think about, it's less straightforward to use constraint programming.
And do you think you could use also novelty search or a genetic algorithm for such kind of problem? Because here, I'm wondering why you try to do a systematic exploration of the space, and you do not try to use some specific algorithms that try to explore the space with some heuristics.
Yeah, that's a very good idea. That's something you can try to investigate. I have tried to generate all combination because like this, I could say whether it has at least one solution. Also, finding all solution is interesting to find symmetrical solution and stuff like that. But you're true. You instead of generating all combination, you can have a genetic algorithm here that that can make the job. And that's part of the challenge, is to find a generic solver that is applicable to any problem. So a bit of dream, right?
I have a question.
Yes.
Can you use the time needed to compute the solution as some sort of fun score for humans?
Yes. Yeah, that's a good idea. But my experience is that it's sometimes this heuristic that does not work.
Like the 6 hours problem you mentioned?
Yes. So
Yeah,
for instance, in the case of the chess puzzle I mentioned, it takes 6 hours, which is a lot, right? And then I asked some of my friends, and yeah, it takes only 1 minute. And even me, I could find it actually, because
because you generate a lot of problem, right, with your algorithm, and
yes,
maybe you need some sort of automated first loop to check the problem you send, because all the human cannot evaluate all the problem. I mean.
yeah, that's I think a good idea. So it's an interesting heuristic to filter out some apparently too hard problems.
Yep.
Yeah, that's something in this loop here. Generate puzzle. You can
exactly there. Yeah.
Exactly there. You can integrate this kind of thing. That's kind of interesting. Yeah. But otherwise, there is some related work actually about that. I found a very fresh survey, March 2020, about procedural puzzle generation. It's related to what I have presented. So there are some people that are seriously interested in doing that.
Well, it was really interesting, and I would be really interested in having access to your notebooks, because I really find it great, and especially the fact and the challenge to reduce the code in a few hundred characters. That's really challenging, I think, and really interesting to explore. So yeah, if when you put it, I don't know, in GitHub or something, I really would like to have access to it to explore it a little bit more, and it's really nice.
Yeah, okay, with pleasure. I just have to resolve an issue, which is that I have used Node.js for generating some images, and of course I commit the Node.js folder with all libraries, and now I'm seeking a solution on how to remove from the history of Git these files.
Okay.
Any idea?
Yes, you can look at to try to on GitHub. You can try to look at if you have commit your password, and you will find a solution to remove a commit from the history.
Mm-hmm.
And it's exactly what you have done, because you have one commit where you push everything.
Yeah.
And so you can follow the tutorial to remove one commit from the history. And
okay.
the best way is to say, okay, I commit my password, how I can remove that from the history.
Okay. Yeah, I think I have already managed to do that, but Yes, yes.
You basically need a guide for interactive rebasing.
Yeah.
doing it.
But yeah, a good way to find one is to search for committing your in-area password to GitHub, and you will see that you will find a solution.
Okay. Yeah. Because the Git ignore actually does not ignore the history.
No, of course.
Of course.
No,
No. Vive Git.
Okay, thanks a lot. And then the same idea of sharing some experience in some week, if you want. I can also share, I built kind of beginning of a framework for building